Hello everyone, my name is Saili Kadam. In our previous videos, we discussed different ML algorithms like KNN, naive Bayes, SVM, decision tree, random forest. So today we will be revising all these algorithms, their working, and basically see how every algorithm is different from the other one. So let us get started. So these are different algorithms that we have covered till now. So we started with first algorithm, that is KNN algorithm. So let us discuss this first and then let us go to other algorithms. So KNN is a very simple algorithm. We have already discussed in detail, but just for a revision. So how exactly KNN works? So it will first decide the value of K. K is how many neighbors that we are going to consider to make the decision. So basically working of the KNN is the main concept of KNN is that we are going to select multiple. First we are going to select a value of K and only consider that many nearest neighbors, and then we will perform voting for classification, and for regression we will perform averaging. So the same thing is written over here, that is it will first consider a value of K and then only will consider those data points. This is simple working of KNN algorithm. So we can use this for both classification as well as regression, and all the machine learning algorithms that we have discussed till now, all of them are supervised learning algorithms. So it is instance based algorithm, then we can use it for both classification as well as regression. It is very fast because we don't consider the entire data set, we simply consider the nearest neighbors, and that's all. It memorizes the entire data set, but the primary focus is just on the nearest neighbors, so it is very fast. Then it requires feature scaling. We have discussed this in our video, that if one feature is dominating or the values of one feature are more dominating, then what will happen, that feature, the result will be biased towards that feature, so we don't want that, so we perform scaling. So scaling is required for KNN algorithm. It can handle non-linear data, and when it comes to high dimensional data, KNN don't perform very well. So under there can be overfitting. Overfitting can occur, it depends on value of K. It gives us good enough accuracy, then memory usage is also high. So all this are the advantages, disadvantages of every algorithm, but the basic working is first we select a value of K and only consider that many values around the, or K nearest values around the new data point, and then we perform voting for classification and averaging for regression. This is how basically KNN algorithm works. Then we discussed naive Bayes algorithm. So in naive Bayes algorithm, the most important thing is Bayes theorem. We consider Bayes theorem here. We obviously, what do? We have different classes, and then we use the Bayes formula, Bayes theorem, and we calculate the probability, and whosoever has maximum probability, that becomes our answer. So the concept behind, so every algorithm has its own concrete concepts, like KNN has the concrete concept behind it is the value of K. Then naive Bayes has Bayes theorem as its concept. So every algorithm is unique in its own way. So we can say that naive Bayes algorithm is a probabilistic algorithm because it is based upon the Bayes theorem. We calculate the probability, and based upon the probability we come up with the decisions. Then we can use Bayes theorem for regression as well, but mainly we use Bayes theorem for classification. Again, as said earlier, that all the algorithms that we have discussed are supervised learning algorithms. Then the training speed of this is very fast. Then prediction also, it is very fast. We generally don't need any feature scaling in case of Bayes theorem. Then so again it has some advantages, disadvantages, but if we see, it is best for both uh, the small data sets and the large data sets. So we can say that naive Bayes algorithm is best for no matter what is the size of the data set. Bayes theorem is good to go for every data set. Then we discussed decision tree. Decision tree is again, so firstly, KNN algorithm. KNN, even if you remember the main core concept behind every algorithm, that is enough. That is, first we have KNN, like first select the value of k and then only calculate the distance, and only consider, like let us say if the value of k is equal to 3, then we will only consider the 3 nearest points, and then we will perform voting and averaging. So that is main concept. So we need not to remember all the assumptions or only main assumptions, like we so like features should be linearly independent, or so for every algorithm we have some assumption, most important assumptions. Even if you remember that much, they are enough. But the thing that you should always remember is the core concept behind every algorithm, like KNN has. So the result entirely depend on the value of k. The naive Bayes theorem, even that is in Bayes, the name says the same thing. So you need to remember the core concept behind it, no matter whether you remember its advantages, disadvantages, but you should always remember how the algorithm works. Then the third algorithm that we discussed is the decision tree. So decision tree is basically, it is a tree based algorithm. So we have Guinea index information gain, where that we use for splitting the data. We start with a root node, then we select a feature that will give us more accuracy, or which gives us the best results. We pick up that feature, then we split based upon that feature, and then we continue it. So this is how decision tree basically works. So we select one feature, we make split on that, again we select one more feature, then again we split our data set. So this continues till the time we don't have any further split. So it is basically a decision. And if you want to learn all these algorithms in detail, you can go to the previous videos where we have already discussed these concepts in detail. This video is just for revising the things. So now we have one feature, we select that feature, we split it. Then again further we simply select a feature and try to split that data. So this is a tree based algorithm. Then we can use this for both classification as well as regression. The speed is very fast, the prediction speed, training speed, everything is fast in case of decision tree. We don't need any feature scaling here. It can easily handle non-linear data as well. When it is high dimensional data, there also it performs decent. But the main disadvantage that we have already discussed is that it can cause overfitting. As the number of features, or as the number of splits increase, the tree starts becoming very complex. So that is why decision tree, it is very, it is very common in decision tree to cause overfitting. We have post pruning and pre pruning. We have discussed all these concepts in detail in our decision tree video, so you can go to that video and just check that. Then obviously after decision tree we discussed random forest. So random forest is nothing but we train multiple decision trees and then we combine their results. That is random forest. So we will have same data set. Every tree will get its own training and testing data, or testing different. So same data set that will create its own training and testing set. Every tree will have its own, then all of them will do some results, like come up with some results, all this decision tree, and we will simply combine the result of all these decision trees, and that is how it is a random forest. So it is nothing but combination of different decision trees. So the internal working is same as the decision tree. The only step that gets added to the decision random forest is that the result of all these decision trees is combined, and then we just come up with one result, that is a random forest. Then it is an ensemble technique. In our upcoming videos, we will be talking about ensemble technique. So this is a very new term to all of us because we have not discussed this before. So just to give an idea, ensemble techniques are some of the techniques where we combine different models to improve the performance of the model. So like in random forest we have different decision tree. So decision tree on its own is a different algorithm, but random forest is combination of this decision trees. Why are we coming up with random forest? Because we need to improve the accuracy or the performance of the model. So ensemble techniques are when we combine multiple algorithms or multiple models to improve the accuracy. That is basically ensemble technique, and in our upcoming videos we are going to talk about ensemble techniques. So decision random forest is a ensemble technique. Then again, it is a supervised learning algorithm. We can use it for both classification as well as regression, and again it can cause us underfitting or overfitting, but again we can balance it because we have different decision trees and we are simply combining this. So again, so the working of random forest is similar. The only thing that gets added here is we come up with only one result. Then we have the last algorithm that we discussed, or the most recent algorithm that we discussed, is SVM. SVM is again a very simple algorithm. So the main aim is to maximize the margin, that is the distance in between the hyperplane. What is hyperplane? Hyperplane is decision boundary. So when we have multiple classes, we try to draw a decision boundary in between them. That is the hyperplane. So the aim is to divide the data into like we should have a clear visible boundary in between different data sets so that we can come up with better decision, or we can say, exactly classify the things in between different classes. This is the aim. Again, if you want to discuss or if you want to go through this algorithm deeply, then I would say that you could just go through our SVM video. So the main aim is to maximize the margin. What is the margin? The margin is the distance in between the nearest data points and the hyperplane. We can again use this for classification as well as regression, and this is margin based. The main aim behind SVM is to maximize the margin. So this is it. And again, the speed is moderate. Then we can handle non-linear data as well. We have discussed that in that video as well, that kernel, even if the data is not separable, not linearly separable, we can use kernels. And we will be going through different types of kernels and when to use which kernel in our upcoming videos. But we have mentioned this in that video as well, that even if the data is non-linearly separable, we can make it linearly separable by using kernel trick. So this is already discussed. So basically the aim behind SVM is to draw a clear margin in between different classes so that we can classify a new data point in different classes, and the main aim is to maximize the distance in between the nearest data points and the hyperplane. This is how our SVM works. So this was a basic idea or basic revision of all the algorithms that we have discussed till now. In our upcoming videos, we will be first talking about the ensemble techniques. That is when we combine different models or combine different algorithms to improve the performance of one specific algorithm. So that are ensemble techniques. We are going to talk about them. Then we are also going to talk about different concepts, like usually the thing that we do, that is first we go through one model and then in next video we go through some concept. So the same thing will be continued. So that's all for this video. Thank you.